Prototypers, we've been learning about digital input, like these small little buttons. Well, this time we're going to use these cool arcade buttons, which actually have embedded LEDs. So we're going to learn about both digital input and digital output in this lesson. Digital output to turn on the LEDs that are embedded inside of these guys. We got them off of Adafruit. So let's see. Here they are. So you can see how they flash on and off. So that's a separate LED that's embedded within the button, and you could do whatever you wanted to with that. You could have it flash to say, hey, you need to press the button, or whatever state you want. I'm gonna show you how to, when you press the button, I'm gonna turn on the embedded LED to give the user some additional feedback. The other thing to point out before we really get started here is that we talked about these buttons, which are pretty ubiquitous, these four-legged buttons. So they have 4 legs. These also have 4 legs, arcade buttons, but the 4 legs are different. So I'm going to start out by showing you a little diagram of that. Yeah, there we go. And I guess I'm in the way. I'm going to hide myself for a second. So at the top, I'm going to move my mouse. So follow my mouse. So at the top, we're going to hook this part to 3.3 volts, and this part is our A1 digital in. And this is the internal pull down resistor configuration. So we don't need to have an external resistor. So that's just the button part. We're going to start there. Then I'm going to show you how to hook up the other side. And you can see this plus over here, and then this minus over here, and these arrows. Well, that's for the embedded LED. And for that, we're going to be able to use digital out in MakeCode and turn things on and off. So let's get started. I'm going to turn my webcam back on. One moment. There I am. Yeah, let's get started. So let's go into MakeCode. I'm going to start a new project. There we have our friendly forever block right there. And remember, because we want to use the internal pull down resistor, we're going to have to use an on start. So we want to initialize that thing. We go to pins, and we're going to say set pull pin. We'll use A1 again to a pull down. Pull down is going to pull down the button to 0 volts when you're not pressing it. And then when you press it, it'll go up to 3.3 volts. So that's what we want. And then we've got our friendly forever blocks right there. And so let's start to build this out. I might move myself over there so I'm not in front of that forever block. All right, so if you remember what we did before, this is the same thing that we did with the other 4-legged buttons. We're just going to grab the input off of that pin. We're going to do digital read A1. And if it's pressed, it goes to 3.3 volts, which is true. So that'll put us inside of that block, and we'll set all the pixels to red. And if it's not pressed, we should set the pixels to black. There we go. So that's the basic pull down configuration, and we can then just hook up the button. So let me bring this back over here, and I'm just going to do the top part of it. Let's see. Will this work? Maybe. There we go. So I'm just going to do the top part of it. Yeah, so we're just going to do the yellow and the red part. So up here, you look, and you see there's that minus and plus. Same thing that I'm showing in the image. So I'm going to put A1 here at the top, just like I'm showing. And then the red over here. And also, we forgot to download the code. So I'm going to download this code. And there we go. I'm going to go back to the drawing. And let's just try it. So when I press this button, the neopixels should turn red. And they do. Awesome. So, but remember, the cool thing about this is it has an embedded LED. So let's try that out. For that, we're going to have to use another alligator clip. And I happen to have a blue one. So I've color-coded things. As you can see, that bottom, bring my mouse over to it. We're now going to hook that part up to ground and that part to A2. We're going to use A2. So A2 goes here, and I'm going to hook that here, and then ground to the other side. And we're going to have to update our code. So what we want to do is when you press the button, we don't want to just turn on the NeoPixel lights. We also want to send a signal, a 3.3 volt signal through the blue to turn on the LED. Now, you might actually want to put in a small current limiting resistor, but in practice, I haven't found that really matters, and it's certainly not going to matter for this little prototype demo. So let's just update our code now that when we press the button, we send 3.3 volts, so a high signal up the blue wire, which will turn on the internal button here. Let's do that. All right, so this is the original arcade button, but without turning on the LEDs. So now we want to do an output. So we have pins, and look at, we have digital write. So we can actually send a digital signal, either a 0 volts or 3.3 volts, out of a pin. And remember, we hooked it up to A2. So we'll do A2, and we'll do it high. That's 3.3 volts. And then when it goes low, we should send 0 volts, so ground. So that's all that we had to do. Now let's download that and turn it over so you can sort of see if this will turn on. Whoa, hopefully that shows up okay. We have a lot of light in this room in my teaching studio, but you could sort of see that. Isn't that sweet? All right, so now let's modify the code one more time to play Flappy Bird. And I think it'll work best if we let's just do the mouse one, I think. This is easier. Let's do the mouse. So we'll set mouse button left down and mouse button left up when you lift up the button. So now when we press the button, it's going to send a mouse click or a mouse press. And when we release the button, it'll release the mouse. All right, so we'll download that. Nice. All right, and then we'll open up Flappy Bird again. So Flappy, there we go, and it's got all these ads, but there we go. Oh, I thought I was gonna get there. I guess it did give me a score of 1. Oh, come on now. Let's try again. These buttons are so beautiful and so fun to play with. Oh, okay. I'm gonna also post some code to debounce the signal. I haven't had much issue with that in MakeCode. But I do talk about that here, which is that whenever you have something that's mechanical, so these switches close, but they vibrate a little bit. And so computers work so quickly that they actually observe that. And it's like somebody pressed the button up and down, up and down, up and down. But really what's just happening is that metal contact is settling. And so there's ways to compensate for that. And I'll post some code. It doesn't appear to really matter. I'm getting great responsiveness off of these buttons, and I'm not getting a lot of strange behavior that's not expected. But I will post code online, and maybe in the future I'll post a lesson about it too. All right, thanks prototypers. Until next time.